Hi folks, welcome back to the 6.3 practice, video number 4. So in video number 3, we solved question number 2 using washer method. Now we're going to take a look at solving the same problem using shell method, okay? So with shell method, let me pick a different color. I think the pink was a little hard to see last time, all right? So shell method is going to have us start the same way we did washer method. We're going to draw a diagram, but when we draw in our blue lines in the diagram, we're going to draw them in differently, okay? So give me a moment to draw those graphs. We have our y-axis that we need to draw in. We have our orange graph, which we plugged in points to find nice points to plot, or easy points to plot. And then we sealed off the top side with this pink color so we could see the whole region we were interested in. We drew in our axis of revolution, which is still the same. And then we drew in our reflection. All right, so now when we have shell method, okay, what's different is we want to draw lines that are parallel. Oh goodness. They are parallel to the axis of revolution, okay? So what that means is that my lines need to be parallel to the yellow line. So this would be wrong because this purple line is perpendicular to the yellow line. So let me erase that and let me draw one that's parallel. So for example, I have this one. Or I could have this one. Or I could have this one, okay? But one thing I'm noticing about all these purple lines is that I have a right curve and then minus a left curve, all right? So my right curve in this case is the orange one, and the left curve is the blue one, all right? So I need to make sure I incorporate that when I'm trying to find the height of my shell. Because again, these purple lines talk about the height of a shell. So I'm going to draw one sample shell here, and I'm going to draw this one. So this one, it connects with that one up there, that was it came from, and there is my sideways toilet paper tube, okay? And kind of like we saw with those Russian nesting dolls, our shells are going to keep going out and out and out, and so that means that we are stacking the radius dy, okay? So let's go ahead and set up our equation for shell method. So volume equals 2 pi, the integral from c to d of the radius times the height, dy. Now, I want to use y values for my bounds, so I have 2 pi. And if I think back to the last video, I knew that my y value at the bottom was 0, and the y value at the top was 4. All right, now remember, for these cases that we're looking at more straightforward cases. That means that my radius is going to be whatever letter is at the end, okay? So I'm going to go ahead and have our radius be the y value, okay? Now I can see that because it's whatever direction my cylinders are going out by. That is the direction of my radius. So I have a y here instead of the r. And to determine the height of these shells, I need to do right minus left. Okay, so that's where this pre-thinking came in handy for us. So our right curve is 2 square root of y minus our left curve is 0. Now, if it would be okay to leave the 0 out, but I just want to prepare us in case we see situations where the left curve is not 0, we have to take care of it somehow. All right, so let's simplify so that we can integrate. So 2 pi, the integral from 0 to 4 of 2y to the 3 halves dy. All right, so I get y to the 1/2 here and y to the 1, and together they make y to the 3 halves. All right, I'm going to go ahead and bring the 2 out to get a 4 pi, the integral from 0 to 4 of y to the 3 halves dy. And I'm going to use my power rule here, which will give me 4 pi times 2/5 y to the 5 halves, and I'm plugging in 4, and I'm plugging in 0. Now, I'm going to use the same decision making that I did last time, which is that because I know if I plug in 0, it's going to give me 0, I'm not going to plug it in because I already know that second part is going to 0. All right, so let's plug in 4. 4 pi times 2/5 times 4 to the 5 halves. Okay. Well, let's take our constants and combine them to be 8 pi over 5 as a coefficient. And separately, let's figure out how to do 4 to the 5 halves without a calculator. So 4 to the 5 halves is the same as the square root of 4 to the 5th power. Now, the nice thing about writing it that way is I know the square root of 4. Square root of 4 is 2. Square root of 4 is 2. So I really have this part becoming 2 to the 5th. So I have 8 pi over 5 times 2 to the 5th, which gives me 8 pi times 32 over 5, which gives me 256 pi over 5. Okay? All right, now before we finish this video, let's talk about decision making here. So I think washer method is a method that folks generally like because they learn it first. And so what we learn and we've had longer to process generally makes more sense. However, in this case, I think I had to do less work to do the shell method. There's one thing that I didn't have to do is I didn't have to do this part. Like, I didn't have to rewrite the equation. And I only had one place to plug in my numbers as opposed to 2 different places over here. Okay? So sometimes shell method can actually be a little bit faster, and I would encourage you to just kind of keep your mind open to it as an alternate option. Okay? All right, so that's it for video number 4, and I'll see you back here where we practice a little bit more of that decision making and shell method.